Welcome back to CMG-MathSpace. We are currently, in fact, treating chapter 2, dealing with core maths and elective math for senior high students, right? In this particular episode, we are treating core math on chapter 2, dealing with real number system, at the moment treating significant figures. Now, my advice is that we did 3 recent episodes on rounding and approximating whole numbers and decimal numbers. Before you watch this particular episode on significant figures, please watch those videos before watching this, else you get confused, right? That is my advice. Now, without further ado, and I would like to sound a caution that I might do 2 parts of this particular subtopic called significant figures. The first part will be introduced to the terms and conditions, the principles and the rules. Then the second part where we do the calculation, right? So, but if I'm able to do all of them within 10 minutes, that is good. So stay tuned. Now, before we do that, let's see what the statement talk about this. Now, we say that another consideration in rounding off a number is when you have to round off to an approximate number of significant figures. You will understand what significant figure is or are. Now, what are significant figures? Well, they are sort of the interesting or important digits. I may forgo this reading, but I just want you to understand these things, right? When you read them with me, then you get a full understanding where I have to cut in and explain. So that's why I'm doing this. I could go straight ahead and do the calculation, but let's do this. Now, for example, 3.14159 has 6 significant figures. All the numbers give you useful information. Now we have 1,000 has 1 significant figure. That is, only the 1 figure is interesting. You do not need to know anything for sure about the hundreds, tens, units, places, whatever. Now the zeros may just be placeholders. They may have rounded something off to get this value. Now let's come to 1,000.0. Also has 5 significant figures, right? Now the dot zero, right, tells you something interesting about the presumed accuracy of the measurement being made. That the measurement is accurate to the 10th place, but there happens to be 0 tenths. That is why I asked you to go and watch those videos before this one. Don't get confused here. Now, let's move further. We have 0.00035, right, has 2 significant figures. Only the 3 and 5 tell us something. The other zeros are placeholders, only providing information about relative size. Don't worry, we'll get the picture. Now, as you can see, here is the important thing to note. Now, a figure's place in a number is important. It tells you what the figure is worth. So, as you read a figure from left to right, here, left to right, left to right, the first figure you come to, that is not 0, has the highest place value. So it is called the first significant figure, that is SV. For example, in the number 3069, right, that's 3067, 3, that's the first figure, the digit actually, is the first significant figure. 0 is the second significant figure, and so on. Also, in the number 0.00406, 4 is the first significant figure. Since it is the first non-zero means it's not a 0 digit, but actually a figure starting from 1 and up to 9, right? Figure reading from left to right. So I've shown the left to right of the number. So from here going this way, here going this way, and we noted that when we are reading the digits, starting from the left is the highest figure when it's non-zero. Now let's read on. Now we have and so on and so forth. Now the 0 after 4 in this particular here figure, 0 after 4 is the second significant figure, and 6 is the third significant figure. Now let's continue. Thus, to number significant figures, that's first place, second place, third place, and so forth, start from the first significant figure. That is the first non-zero figure, and count to the right. An easy way to approximate a number is to deduce how many significant figures it has. When this is done, the number is said to be given correct to a stated number of significant figures. Let's go on. Now, to correct a number to a stated number of significant figures, these are the rules, don't worry. It's important to note them, but I will explain them, right? When the moment you get a concept, you don't have to chew or memorize these things. It will come naturally when you see the figure and you are solving the math. So find the last digit. The last digit here means that the actual place or significant figure that you have been asked to deal with. So that's what is named as last significant figure you want. Now, then look at the next significant figure, which is what? The next digit. That is it, to the right. Now, if this figure is less than 5, leave this last digit figure you want as it is. If this is less than 5, if this is 5 or more, add 1 to the last significant figure. So also note this. Note this. The last digit means the actual place of figure or place of value that you have been asked to solve. That's the significant figure. So it just, I don't know why they use the last A. This sounds confusing. So that's why I'm explaining that. Is the significant figure that you have been asked to correct to. That's what you are looking at. That particular significant figure. That's what you are looking at. Then when you say the next significant figure is the next digit after this particular figure, significant figure that you have been asked to deal with. So that is it. So now keep this in mind, because to get to a time when we are dealing with whole numbers, you have to get this thing well understood. So let's move on. Now always check that your approximated number is of the same order of size as the original number. So here also is a point 2 that you need to note. To get to a point, I will solve a question, and you may think, why didn't I bring this figure or left this figure out, or digits out? It's probably because of this rule. So take note, I may revisit it. So always check that your approximated number is of the same order as the original number, right? So no problem. Now, here are the basic rules for significant digits, whatever. Now, all non-zero digits are significant. All zeros between significant digits are significant. All zeros which are both to the right of the decimal points and to the right of all non-zero significant digits are themselves significant. I will explain this in math. Now, here are some examples. Each number is rounded to 4, 3, and 2 significant digits. So here, let's see. I'm sure the time is up almost. So here, we have round 742,396 to 4, to 3, to 2 significant figures. So each of them will do that. So for 4 significant figures, you have this. 3 significant figure, you have this. And then the 2 significant figure, we have this. Right, so hold on. Let me check the time left. Okay, so we can do this, these 3. Now, we have 742, right? 396. Now, look, let's solve the 4 significant figure. So the fourth one, we said that we start from the the left. So 742. So for significant figures, we start from the left, looking for the real numbers, right? Actual digits, not zeros. Starting from that, so 742,369, and then we are looking at what? The 4 significant figures. So 1, 2, 3, 4. So 3 is the 4th significant figure. Now, after looking at this, let's look at the next digit to this 3. It's 9. Is this 9 less than or equal to 5, or greater than? This 9 is greater than that. So it means that we add 1 to this 3, making it 4. So if you have 4, it will be 742, 4. The rest here, we have to add the zeros, like we said, so that this is the rule. We said something here that always check that your approximated number is of the same order of the of size as original number, right? So we have to bring the zeros to get the whole figure, the whole place